So let me introduce you now to our first guest. Charles Crawford III's engineering education started in high school with electives in drafting and electronics. He graduated high school with most outstanding student in technology, graduated top of his class with a bachelor's in science and electrical engineering technology from DeVry University. And he's currently a PhD student in electrical engineering at the University of Texas at Arlington. He'll be presenting today on his continuing work with Alexey Chekurkov's Graviflyer kit. So without any further ado, let's welcome Charles to today's event, and I'm going to hand things over to him to get started. Okay, and Charles, I am asking you to unmute, and go ahead and take it away, sir.
Thank you, Tim. All right, let's start sharing my screen here. Screen share. Okay. Screen. How does that look?
Yep, looks great.
Okay, I can start at the beginning here. Okay, there we go. Okay, yep. So as Tim said, I'm Charles Crawford III, and this is Alexey Chekurkov's Graviflyer kit. The kit design explained by me, and it's January 1st, 2022. So happy New Year, everyone. I have my contact information here. The shapec2@yahoo.com is my email, my Facebook, my YouTube, and a Thingiverse page. And there's also the share drive for all these files I'll be going through today. So in case you're not familiar, Alexey Chekurkov, shown here, is a Russian self-proclaimed garage scientist, where he's invented this Graviflyer, which he says based off designs from 1922. And he's combined several different ideas to make this device, called the Graviflyer, work. And as you see here, it flies and it could lift itself pretty high by adjusting the parameters of all these electronics. And he's also got a lot of controversy on it because he's the only one that's seen it fly, and he's posted his videos on YouTube. So people have asked him, to go outside without trees and where they think the device would not interact with metal reinforcement in the floor, as he's shown in his earlier videos. So in his more recent videos, he's out in the field with no suspension around him, no trees around him, and he's put hula hoops around the Graviflyer. He's put his arms around it. He's leaned over it and spun around it. He showed there's not a pole suspending it up. So it looks to me like it's alternative propulsion that it hasn't been seen before. So it's using a form of high voltage AC, DC, and ultrasound to create this lift. And here are some different designs he's shown in some of his videos. This is the earlier Graviflyer, which was stolen from his garage, and we still have that one hasn't been returned. And this one was one he showed later in his videos, but barely lifted and kind of fell over in some of the videos. And this is the latest one he's been showing in his videos, and this is actually the one he shipped to me when I bought this kit for 2,000 euros. There's a slight difference in the bottom here. He modified it since then, and he's since cut off these little edges, but other than that, it's pretty much this model. And in the field, I took a screenshot here from this video showing the electronics he used. And here he had it powered all on this car battery, 12 volts, so it's a low power system. This is the Slayer Exciter Tesla coil, or as he calls it, catcher, and these are the electronics for it. That's the power for it. And this, I believe, is the ultrasound device, and this is a high voltage device. And this box just has the regulator to convert the power from the car battery into 12 volts for these systems. And this Tesla coil and electronics for that are part of the kit he sent to me, but these other ones he still has. All right, so here is the Graviflyer design. Okay, Graviflyer schematic shown by Alexey Chekurkov from his channel. So the design's already free and open source since around 2017. He started showing the videos, and this video was a little after that, when subscribers were asking to share more of the design. So There's one change I made here is this NPN transistor. There was a comment he made where the transistor was wrong with an error when resizing it, so when he redrew it. But this does not mean that it was assembled with an error. So from the schematics I've seen, this is how the transistor should look. Okay, so I'll break it down to the 4 main components of this. The first here in blue is the high voltage circuit. This green part is the ultrasound. And the red part here is the Tesla coil, or catcher, as he calls it. And the 4th part is more of a mechanical frame than electrical schematic, but he included it all together with that. And all these combined is what creates the lift of the Graviflyer. And what I got with the Graviflyer kit, I updated the circuits. So after getting these kits, I took them apart, understood them better, and updated these schematics. So they were very close. One thing we noticed about the flyback transformer and the high voltage circuit was included the diode and capacitor, which is actually included in the flyback transformer. So you really didn't need to show that. Chris Hardeman and I spent many months trying to reproduce the diode and capacitor configuration, but it wasn't needed. Later, I showed him this updated schematic, and he said that those diodes and capacitors were included in this flyback transformer, not needed in the schematic. And here's the ultrasound circuit. So the one he sent me is a little different. He's using this regulator to control the voltage of the motors and the power to the ultrasound circuit. And I updated the part numbers, which will go into more details into each circuit. And the Slayer Exciter Tesla coil, I updated those values as well. And this he actually sent me with the kit, which gives more details of the construction of the Graviflyer frame and the motor distance, and the layout of all the components and the wires. So we'll go into more detail on those. The other component besides those 4 was the gravitometer, as he's calling it, to measure the field around the Graviflyer. And it shown here, I showed the schematic for it, and all the electronics are mostly inside this compartment, the potentiometer, capacitor, red and green LED indicator lights, and he also updated me on instructions on how to use this with measuring the Graviflyer. And you see in some of his later videos, he's using it to tune the device, since the electromagnetic fields around the Graviflyer are invisible to us. So there's more construction of the gravitometer. They have 3 antennae, and they're about 9 inches long. And I'll apologize, I switched back and forth between inches and metric and imperial. So the thickness of these are about 0.79 millimeters. And again, these are inside that component. And the back just has a little hook to hang everything, and the 3 wires going to the antenna, and a shovel handle modified to hold it. I reverse engineered the design, and it's available on my Thingiverse page, Charles III. And you could 3D print this rather than making that other frame to help hold the meter and electronics. So these are the instructions. He emailed me on how to use it. To quote Alexey, he said, "Hi Charlie, I am sending instructions for the gravitometer. The device does not need batteries. It works from external electromagnetic fields. The 3 antennae help to determine the field boundaries. The device has 2 indicators, red and green. Below that is a potentiometer for the analog meter. High frequency energy emitted by the Graviflyer is captured by 3 antennas. The red indicator lights up indicating the presence of an electromagnetic field. The green indicator lights up when the upper and lower discs begin to form torsion vortices. They are not shielded by anything and affect electromagnetic devices. The analog meter begins to go off scale. In this case, you need to start reducing the power in the electromagnetic field captured by the 3 antennas by turning down the potentiometer. If the arrow of the device continues to go off scale, then you need to turn off the middle antenna by opening the switch on the right side. If, in this case, the gravitometer continues to go off scale, you need to move the gravitometer away from the device. This means that the torsion fields have formed an energetic cocoon around the device, which has a certain intensity of shielding gravitational waves. It is important to point out that the zone of powerful torsion fields is harmful to the body. It is necessary to limit the time of the experiment. The antennas placed in the field of the Graviflyer will show an intense zone of the apparatus, which is not desirable to cross. indicator should be adjusted when all three antennas are turned on and the analog device is positioned in maximum sensitivity. As the electromagnetic field increases, the sensitivity should be reduced. Two lit indicator signals that the device is tuned to the levitation effect in which gravitational waves bend around the body of the Graviflyer. That was from Alexey Chekurkov on October 30th, 2021. Okay, let's go into the high voltage circuit. And the data schematic is again shown here. It has a switch, two resistors, a transistor, and the flyback transformer. Here's kind of a side view of the transistor, which is connected to this giant heatsink, and it does produce a lot of heat, so it needs a lot of heatsink to pull from that. The two resistors are 5 watts. So zoom in here, they're 5 watts, 220 ohms JW, and 5 watt 220 ohm JM. So that one is the 22 ohm, and this is the 220 ohm. That's shown here. This is the power supply he supplied with it. It is like a European adapter, so I bought adapters for the US plugs. And it can do up to 2.5 amps at 3 to 24 volts. And behind this board is how he soldered those resistors to the rest of the circuit. The whole thing in its container looks like that, and he labeled it as 20,000 volts. And the negative is the blue, the red is positive, and the input power, and there's an on-off switch. And here's the signal that comes from that. It's a sawtooth with a high rise time and a slow fall time. So that is pretty popular for lifters. So that is, I think, helps a lot with the lift of the Graviflyer. But unlike lifters, this thing weighs a lot more, and it's about 2.5 pounds or 1 kilogram. The ultrasound device is on the top cone here. Under the cone, after I took that off, so curious to see what it was. Under that, there is a stand which was glued to the cone, but had fallen off, I guess, when he dropped it. In some of the early videos, he was testing to see when he unplugged the power, it would fall from a height from a few feet. Underneath that stand, there's the piezoelectric device, which is just glued to the bottom of that. And when I re-glued it back, this is about the distance from the cone. It's about the middle of the cone. And the piezoelectric device he's using is 27 millimeter diameter. And the whole circuit he sent me is here. And this knob controls the volts to the motor speed. And this potentiometer on the right is control the frequency of the ultrasound. So kind of two circuits in one box here. And again, that's here. The power brick was this, and it does from 16 volts. In this original circuit, it showed 12, and it's probably around there after it drops. It's kind of an older power supply. All right, so let's go more into detail into that circuit. When you open the lid, it's a bit of a mess here. This is where the power brick is, and the two potentiometers. And behind the circuit boards is, again, the solder connections to that transistor, and there's your solder connections to this capacitor, which is a 160 volts, 100 microfarad capacitor. And I really like this toroidal transformer he hand wound. So he took a inductor that was already wound with copper twisted enamel coated wire, and he made his own transformer by winding that with this wire. And that helps with the piezoelectric high frequency. These are the potentiometers he uses, 10 ohms. And he got most of his parts, looks like, from a scrapyard, and they were repurposed. So these were used parts, but they work well still. And these are the LM317T. It started to get damaged because this component gets really hot when running this circuit, and it's on a heat sink here. This is the other transistor used in the ultrasound switching. And this is a power resistor for that circuit, 240R, JVA7. All right, so he said this is another quote from Alexey. The ultrasound starts from 200,000 hertz and above. If you listen to the piezo element in complete silence, then your ear can hardly distinguish a barely perceptible rustle. I took a diagram from the internet. Here's a link. to the site, and you get a Russian link to that circuit. So the device has a built-in adjustable power supply unit from 1 to 30 volts, but the voltage must be set within the range of up to 9 volts. And I replaced the constant resistor in the ultrasound circuit with a variable one to adjust the ultrasound. Unfortunately, I do not have a frequency meter to measure the parameters. You must not only look for the frequency, which resonates with the torsion vertices created by the spinning discs, but also adjust the duty cycle of the pulses from the catcher, and also adjust the voltage of the high voltage generator so that there is no breakdown between the plates and the current is not too low. I myself have been dealing with the physical processes created by the apparatus for half a year, and that's Alex Chekurkov on December 31st, 2021. So just yesterday, he emailed me that. So here are the Tesla coil, or side or Tesla coil is the more distinct name for it, or as Alexey Chekurkov calls it, the catcher. I measured having 1.2 megahertz with no wire down the center, but the center wire is needed to supply the voltage to the center plate. So when you have that in, there's 1 megahertz at 2,480 volts AC, peak to peak. AC signal looks something like this. And the plate gets about 1 megahertz, 270 volts AC at peak to peak. So the primary on this Tesla coil has 4 turns at 18 American wire gauge. And the secondary has about 1,055 turns at 24 American wire gauge. And it is 15 inches tall. And this is the transformer he's using, the main component, which is a 2N3055 transformer. And this is more, someone asked me that they had trouble reading the schematic diagram and they were confused of the transistor layout. So I drew it like this. It shows more picture diagram, how to construct it. And inside the container of Alexey's, these are his electronics for controlling it. So it's a little messy, but everything works in the end. So I'm happy with it. It's very important to have the exact dimensions when building a Tesla coil. So anyone that's trying to reproduce this, I thought I'd give them more dimensions on the Tesla coil that Alex Chekurkov sent me. It's about 2 inches in diameter. The thickness of this wire is 0.36. The height is about 15 inches. And here underneath the primary is the connection to the secondary. The diameter of the primary is 62.9 millimeters, and the thickness of that solid copper wire is about 1.06 millimeters. And the height here is 88.12 millimeters for the primary. And again, I put designs and other parts and schematics on the Thingiverse page. So you can 3D print. I redesigned and printed this container and stand for the Tesla coil. So the fourth part is the Graviflyer frame, which, with updated designs from Alex Chekurkov, he's showing the piezoelectric element under the cone. And strangely enough, this top part is mostly solid, so the sound somehow bounces around in this cavity. Maybe Todd Desiato thinks it's reflecting off this whole circular top part, which you can see here in this light green color. And he drawn here the wires here in this green crayon. He drew it to go down. That's the motor power cable, which is also connected to the ultrasound in a twisted pair combined wire. So 2 are for the positive and negative for the 12 volt for the motors that are connected in parallel, and the ultrasound positive and negative, which run up to the top there. And then the other wire you've seen in the video is the catcher, the Tesla coil wire. It goes directly from the bottom, connects to one of the legs of the Graviflyer. And the other wire is the high voltage. It's a twisted pair, about 18 gauge, positive and negative. That is in this. So in the video, you see the 3 wires, but inside those wires there are several other wires shielded there. And this is the brand for the top and bottom motor. They're the same, even though the bottom one looks different. He's just using a siren, which you get like a 12-volt siren put on your car. He modified that plastic casing to just go around the bottom motor and to help just hold the frame. But there's no electronics from that circuit underneath it. It's just a motor. And he said the voltage about 30 kilovolts. The speed of the disc is about 2,600 to 2,890 RPM. But there is nothing else to measure. Under measuring the discs, though, that's an important thing. A lot of people are asking, what are the diameter of those discs? About 8.5 inches, both equal. And he has the north-facing up magnets, 6 of them evenly spaced near the edge. And there is some steel casing around those neodymium magnets, I think they're an N42 neodymium. Measuring the diameter of those, about 25.21 millimeters. And the height is about 7 millimeters. And the brushes make contact with the outer sides of the plates away from the center plate. And they're connected with this brass brush. So this is for the bottom plate and this is for the top. And it just has a lug connected to that runs along the side of the frame. It's for the high voltage. All right, underneath we have all the connections for the high voltage, positive and negative, and the 4 that goes to the splicers, the ultrasound and motors, and the Tesla coil goes directly through the center, out the side, and connects to a leg. This is the diameter of the center plate. He had to bend it to ship it to me. So he said, so I had to unbend that to get it going back to work. And it's about 15.5, almost 16 inches in diameter. A lot of people were asking about this oxidization and threw us off for a long time. We thought it was some type of steel plate, but it's actually a aluminum plate. And this oxidization is actually some residue from epoxy or something. I believe when he found it from the junkyard or wherever, that's what he got on it. So the motors, the top motor was completely cut off the fins. The bottom ones were badly damaged as he used like a Dremel to cut around this acrylic insulator. And he Roman numeral labeled 1, 2, 3 holes for the screws that hold the bottom plate onto this. So a lot of people were saying, was it the fan blades that were suspending it at the mirror? No, definitely not. The top blades are completely missing. Bottom blades are badly damaged. These are the other hardware components, the 3 legs, which are stainless steel. The rest of the components are slightly magnetic, so they're a mix of steel and other metals. And we just gave washers and nuts, no lock washers, no lock nuts. So you have to make sure that they're very tight on the frame, or else the spinning of magnets and electromagnetic fields will start to unscrew those nuts. All right, again, I have a design on my Thingiverse for the frame, but that's a little older design. I was using brushed, the 3-phase brushless motors, which is not a good idea because the high voltage near those, they use PWM signals to control the speed of those, and any high voltage or spinning magnetic fields or the AC field from the Tesla coil all interferes with that signal, so it'll randomly speed up or stop and stall if you use that. So I recommend using the fans blades he's shown. So Alex Chekurkov also gave me an update on the Graviflyer frame. So here he said, "Hi Charlie, I saw your video where you're trying to tune the Graviflyer to remove the neon lamp from a catcher. It extinguishes the power. And now how to tune the parameters for the levitation effects. The levitation of the apparatus is based on the interaction of magnetic and electromagnetic fields. 6 round permanent magnets interact with an electromagnetic field, untwisted in different directions. This interaction begins to create torsion fields of different directions. The middle disc to which the impulses are supplied from the qualitative devices does not allow the fields to mutually neutralize. The ultrasound passes in these fields at a certain frequency, creating a swing of the medium in which the gravitational waves of the Earth do not have time to influence the Earth and push it to the ground. You just need to create these conditions. 1, correct select the duty cycle of the pulses from the kicker. Set the required voltage on the high voltage generator. set the correct frequency of the ultrasonic generator, combine all the adjustments until the parameters of all processes have shifted to other values. And as you can see, it's like picking a code for a save, stumbling upon a combination of these parameters after 3 years of experimentation. Unfortunately, I did not have the necessary instruments to measure the characteristics of the processes. It took a lot of time when I first learned to just make the apparatus jump and then freeze and finally stabilize at a certain height. This device is undergoing processes that I myself still do not understand. Perhaps you will understand it better than me with your equipment and improve the apparatus. My plans for the future are to build an apparatus of a Mercury engine, like the discs of Nazi Germany. I already ordered Mercury. I collected quite a bit of information on anti-gravity technology of the Third Reich. Many subscribers to my channel shared secret technologies, and I already understood some. Good luck with your work. That was Alexey Chekurkov, December 21st, 2021. And again, these are the links to Alex Chekurkov's YouTube channel, where I first seen all his videos. He doesn't have any other videos that I'm aware of, except for maybe a RooTube, where some of the deleted YouTube videos he put on there. This is my email if anyone has want to contact me for questions or concerns, and my Facebook, where I've been showing updates, but mostly on my YouTube channel. And if you want to start building your own Graviflyer, you can use some of the designs on the Thingiverse page, the 3D printed parts like the gravitometer and the Tesla coil. The Google Drive also have pictures, more detailed instructions on all the pictures shown in some of this presentation. So I'd like to also do a live demo showing I've got the whole complete kit here and ready to set up. So let's jump to that. I've also wanted to go back to, this is the link he sent me. And this is Alex Chekurkov's website. And here we go. And these are the share folder with the different parts and parts lists, even cells for all those to go into more details, and pictures are all there. So it's free and open source. So let me switch to sharing the video now. Stop video, machine. Okay, and what I need to do is switch this. And I can maybe switch on to my phone if we need to get a better view of some of the equipment. Okay, let's switch to Tim might have to share the full screen. Okay. Okay, hopefully I'm highlighted. Okay, yep, in the chat, maybe if you could give me a thumbs up if you could see it well, the video.
Okay, and so you're doing you're trying to play video, Charlie, or?
And here we go.
Okay.
All right, try to get you guys closer. Here is the kit, and it is connected to the Graviflyer, which is down here. All right. So in order to run everything and turn on the power, we have power going to the motors, starting to spin them up. Sometimes this bottom motor is a little close, but it looks like it's on. Then we have the wireless energy to test the coil. So you can see when I get near it with this neon bulb. And I believe the setup order is to first turn on the motors, let them get to full speed. If you
wait and turn everything on at once, and the high voltage and AC and the center plate will interfere with the speeding up of the motor, you know, more resistance to drag while it's placed to charge. So I first let them get to full speed, and then I up the power to the high voltage. She suggested 9 volts. There. I've also got this radiation meter and a lead vest to help with protection while puffing. So far the meter hasn't protected much while tuning it. It seems like once you get the correct setup for the lift, that there's a sustained higher voltage field that generates around it. Yeah. All right, so switch is already on. We have the power cord here and insulated here, some heat sink. This is the ultrasound and the motor cables combined, and the power to the motor and ultrasound circuit. This is the voltage for the motor speed, and the frequency of the ultrasound is about 200 kilohertz. So human hearing is about 20 kilohertz, which is much higher than human could hear. So adjusting this is kind of the more complicated part of it. Here we have the gravitometer, which does light up red when you're near the Tesla coil. And you'll see the meter start to rise a little. There we go. Okay. So it's working. And the wire down the center is not in physical contact with the output, which is collecting the wireless energy from the Tesla coil. A lot of people have asked, how could Alexey touch the center plate if there's high voltage AC? That's because it's not in direct contact with the power system. So it's a high voltage, low current, and high frequency. Okay, so let's get in the cross. I've also got other equipment to measure like the speed of the rotation of the disc, tachometer. Another good equipment to use, suggested by John Hutchinson, was actually an AM radio. So turn that on. So you can hear the hum, and that's actually from the radio wave of the Tesla coil. And I can prove that by turning it on, and you'll hear it. It goes back to static. And then I'll turn it back on. You can hear the hum. So it helps kind of audibly hear the electromagnetic field that is developed around Graviflyer. That's out there. There's also infrared camera. After this, I can show you clear one infrared video of some of the electronics that helps give a better view of where the heat is coming from on the circuit. So right now it's not too hot, but the heat sink here is starting to heat up. And some of the electronics in here, as well as the heat sink that is transistor to the Tesla coil, gets pretty hot. The Tesla coil generates heat near the top resonant frequency of it. Okay, so that's it. And yeah, I want to be clear, I haven't got to lift yet. I'm still experimenting with it tuning the device and getting practice with that. So the only thing I've noticed is it's spinning here and vibrating. Sometimes there'll be different variations of vibration. But I've double checked to make sure there is an AC signal on the center plate. And I've replaced the magnets that were originally given. They were cracked. They were damaged from shipping. or maybe from Alex Chekurkov testing. And the rest seems to be working quite well. Okay, so electric is working. I connected to a different ultrasound circuit with to check the lower frequencies and hear that was making noise. And another thing I'd recommend is when building a Graviflyer to stick with the 3-leg design. Really good for seeing that it's 3-point contact with stability. And because there's 6 magnets, it might have something to do with their effect. So when the magnets line up with each arm, and they're also made from stainless steel. So the rest of the parts are aluminum, and aluminum. So this is what it says most of the time. And as Alex Chekurkov has shown with these cables, you could have them much longer and so he could fly it much higher. But I'm keeping them a little shorter just to make sure the signals are reaching the Graviflyer. But one thing I did learn is a lot of the electronics and circuits and theory of it is really low power. So a lot of people overdo it. So if you put too much high voltage to the circuit, then it will start to overheat and spark and arc. So you have to really use high voltage, low current circuit. And I recommend the flyback transformer with this electronic configuration for the sawtooth wave signal you want to achieve. And then for the Tesla coil, the height is what really affects it, because the amount of turns for the secondary and primary. So I've built some replicas of it. But it has a smaller box, only about this size. And still has a large enough feature. So tuning even Alexey says it's taking several hours, so that will see anything in this short video. But you get the idea of the setup and what it looks like running. But I believe he must have spent many hours doing this and then only showing the clips where it looks out. While that's running in the background, I could go back to sharing some of the videos of the thermal imaging. Alexey Chekurkov also said that there's a high voltage field that builds up around the Graviflyer does destroy some of its electrical equipment, so he stays about 10 feet away from it when it's getting near to lifting up. And you could tell that from the gravitometer signals that he's measuring. But currently, when I use the gravitometer on it, it doesn't light up at all. So it's still a work on the tuning process to develop that field. Go back to sharing screen. Here is the thermal video, clear one. Okay. So this is the player excited Tesla coil, and the heat is mostly at the top here. So looking at the infrared shows the difference than just looking at the physical Tesla coil. So this is some of the equipment that I've used that Alex Chekurkov hasn't tested his equipment yet with it. And this is the electronics for the player Tesla coil, where the heat sink is near the fast here with that transistor, which gets pretty hot. The majority of the heat coming from that. The power bricks for the high voltage here is about 11 volts. And the transistor and the switch get hot as well. So the circuit gets the most hot because it requires a lot of power to switch that transistor to power that. Here is the flyback transformer. Here's the transistor, and this is all just the heat sink. I had just a different ultrasound circuit I was using to make sure it was the electric device was working at a lower frequency. And this is Alex Chekurkov ultrasound and motor speed control. So when that transistor that's located near the front, it's the most of the heat. Once you get closer to tuning, that you'll see more around the Graviflyer. Alex Chekurkov has shown that the plasmoids that produce are like tiny spheres of balls of energy that somehow help with lift effect, which I haven't noticed yet. But if they would appear, then they would show up in the infrared thermal camera. Mostly the heat on the Graviflyer is just from the 12 volts, so running at 12 volts pretty fast. And there's a bit of a backward torque because the magnet near the aluminum plate. And the thickness of the plate is 0.69 millimeters. And the legs and the arms are all electrically connected to the AC signal, and it goes in the C along with the center plate. And the APEC, so as soon as I get this thing flying, I'll definitely share with everyone. See that update. Okay. Go back to
Hey, Charlie, we're getting some
sharing.
mic interference. Is that?
All right, here we go. So this is
Can you work on your mic a little bit?
my YouTube channel where it shows the playlist of the videos. I put together clips of all the flights of the Graviflyer. Up to this latest one. It's now been about 7 months since he's posted anything because he's told me this Graviflyer, and he's been working on different designs. As you saw, he's trying to build a larger one that's using spinning records. So he'll be quite busy on that for a while. This was the 2017 video. And then he's gone into other theory, the videos, and to translate his videos from Russian to English, to use the subtitles, auto-generate, auto-translate into English. I helped understood most of the videos, and this is the best translation. So luckily we had Daria, which speaks Russian, helped translate the videos in more fluent English. And besides those videos, I've also included Anthony, which gives a 2-hour lecture on his understanding of the Graviflyer. That's a little older now. It's been a few years since he posted that. But he's also posted it into Chinese.
Hey, Charlie, it's Tim. Sorry, we're having trouble with your mic.
And DK Spicer is also really good breakdown understanding. He's still working on his model of the Graviflyer. Machine Systems also showing his version of the Graviflyer. Hopefully this explanation of the kit will help these groups work on their Graviflyer design a little more detailed. And here is another one from that. Oh, there's a guinea pig that was working on a 3D printed spinning disc, and the system wasn't quite right, as Alex Chekurkov said. So we probably shouldn't use 3D printed disc for it. That explode there. So the thin aluminum he's using is good, and he's probably not spinning as fast as in this video. It's spinning at probably 2,500 RPM. Yeah, I think it's spinning around 10,000 RPM. So yeah, don't go that fast. Too dangerous for the projectiles of the magnets. That's why I hit the screws down the center of the magnets to help hold them to the plate. And here's another Sphinx picture. They're attempting the Graviflyer design. Magnetron. And a lot of Chinese groups. I don't speak Chinese, so I don't know this username. But they've also been working on the Graviflyer. A lot of people put on scales to make it lighter at first. Using a digital scale is not recommended because high voltage will easily distort the electronics of the scale, and the vibrations in the scale. Then that's another issue. So you want to use a mechanical scale that has some vibration compression. That's for my testing. I've just been testing on the floor to see if I can get the lift. I haven't tested it with a scale. Jun Pizza though is another group, I believe a Japanese, maybe Chinese group. Yes, Chinese. That's been working on their design of Graviflyer. They're using actual discs. The translation Russian to English or Chinese disc is what he was talking about for the textured aluminum. They literally thought it was a CD disc, which caused some issues there. And here's John A. Motti. This was Chris Hardiman. This is now with Falcon Space, Focal, in their New Jersey lab. He got pretty close, pretty accurate to the design. Not even like his rubber insulators. He's using some larger Amazon motors at 12 volts SDC. I believe we could get this design to fly and if I figure out the tuning process for Chekurkov. We'll have to revisit that. This is some of my earlier tests using a 3D printed frame and the three-phase motors. And even then, it was distorting the flat screen TV. High voltage would turn it off and on. So we're going to be careful with arcing and spark the high voltage on the plate. Now, I was using this type of tester coil originally, but any wires put down that will catch on fire with the resonance of it. It's not adaptive. The tester coil has the transistor, it's self-resonating, will adapt to a wire down the center. So I don't recommend using this type of tester coil. And other groups have talked about it along with the other anti-gravity experiments. So as you can see, I'm not the only one working on this. Even so far as the debunked field, they were trying to understand Graviflyer, so they got their quick prototype of it, and they showed that even like the pulses in the high voltage could create a lift with the magnet. And this kind of led him to think that perhaps the Graviflyer was real in this quick test, but this might just be electromagnetic field on your magnet create jump, push yourself off the ground.
Okay, guys, let me do this. We're having some trouble here. We can't get through to him, so I'm going to. Oops.
All right. Well, I think that's about everything I wanted to share.
Whoa, Charlie, here.
Oh.
Hang.
probably the ultrasound or the turn this off. The background noise
Oh,
might make it
okay.
difficult to hear.
Charlie, sorry, it's Tim. Can you hear me?
And we can go to the question section, and I'll let this run. It's a bit of a noise. I have to turn it off to
Okay.
see if it's too loud for it to hear anything. This is pretty much what the testing looks like, and I'll keep experimenting with it so we get some lift.
Oh, okay. Charlie, can you hear me okay? Yo, Charlie. Yeah, Charlie, can you hear me okay? Okay, let me see. Charlie, your mic is having problems. Yo.
Okay. Yeah, I guess the high voltage near some of the equipment
Oh, okay.
might have distorted some of the
Charlie,
microphone.
can you hear
That's the
me?
problem with working with this.
Can you hear me
Yeah.
talking?
So we could be good to move to the question section. I'll switch to a different headset. We unplug it, plug it back in.
Yeah, please switch headsets. Okay, can you hear me, Charlie?
Yep, yeah, I can hear you now.
Okay, yeah, no, you've had audio issues for like 20 minutes, and that's okay. That's okay. So, okay, well, let's do this. I'm going to put this thing on gallery view here. Everybody, please give Charles Crawford III an enormous hand. We did have some audio issues. I do think Mark Sokold said in chat it was probably the Tesla coil. And I think it was. When you turned it off, your audio got way better, but the receiver still wasn't working. So, again, my apologies to everyone for the audio issues.